Hello everyone, welcome back to Let's Unbound. Yes, we are in 1.9 subtopic of AP Precalculus, which is rational functions and vertical asymptotes. And in this rational function series, so we have learned many things, how to find domain, then poles, and now into vertical asymptotes. So do watch the video from the beginning till the end. Let's do this. What is a vertical asymptote? As the name suggests, it's a vertical line, and we call it as asymptote. A graph will approach the vertical line, but it will never touches or crosses it. This is vertical asymptote. And so when we are analyzing this vertical asymptote, we will use an important thing, which is multiplicity. Multiplicity of factors. Okay. So of course, our numerator and denominator are polynomial. They can be broken down into linear factors. They might have some multiplicity, odd and even. And we will analyze the behavior of the vertical asymptote or how the graph behaves near the vertical asymptote using this multiplicity, right? So I hope you can recall this. We already discussed this in previous videos, right? Now, a vertical asymptote is a line in the form x is equal to a, where the function approaches plus or minus infinity. So when it tries to approach a point, it will suddenly go to positive infinity or negative infinity. Such kind of position is called as vertical asymptote. And when it will occur, when your q of a is 0, q of a means what? Denominator is 0 and your numerator is not 0. They can't be simultaneously 0 again. Got it? So that's it. And this is how the blue lines you can see here is vertical asymptotes, right? You see the red is a graph. It's working like smooth, but suddenly it approaches infinity when it moves closer and closer to the left blue line. And also, okay, then what happened? So it can't cross, but it start emerging from downwards. Like it approaches the other side infinity, but it never touches the line. Same happens here. This side it approaches plus infinity. To the another side of the vertical asymptote, it goes to minus infinity. Right? Yes, we will analyze how this happens. Both the sides will it go plus infinity or both minus infinity, or where it's approach plus infinity, where it approaches minus infinity. We will learn that. Okay, coming to how to find vertical asymptote. From the graph, you have to look for vertical lines that the curve is getting approaches, but it never crosses. So near these lines, you can see this one. The graph shoots up to plus infinity or drops down to minus infinity. Okay, so this behavior is telling we can't define the y value at this particular x value, right? Now, analytically, from the equation, if you got this rational function equation, factorize first numerator and denominator both separately. Cancel out any common terms. You remember, I hope, that is what whole is. Set the remaining denominator equal to 0. Solve to find x values that make the function undefined. Okay, now the denominator you should set to 0 and those x values will be undefined and they are our vertical asymptotes. Right? Very simple. Simplify and the remaining terms you have, right? Remaining factors in the denominator set it to 0. Right? That's simple. Now, how does multiplicity helps us in analyzing the behavior? So multiplicity, if it's odd or even. If it's odd, the graph switches off the asymptote. So if this is your asymptote, it will behave in a different way. Like it approaches plus infinity means other side minus infinity. Or it approaches plus infinity here means it will approach, minus infinity here means plus infinity. So one side up, one side down on either side. What if I have even multiplicity? Both the sides say both approaches plus infinity or both approaches minus infinity. Okay, in this way we can analyze how the graph behaves near the vertical asymptote, right? Okay, into the problem. Very simple problems, but this will be helpful in strengthening your conceptual skills here. Right, so first the function is given, find the vertical asymptote. What is the first step? Simplify. It's already in simplified format, so you can directly set your denominator 0. Whichever factor you have, everything you should set to 0. X plus 2 is 0, x minus 1 is 0. X is equal to negative 2, x is equal to 1. These are the vertical asymptotes. Very simple. Right? So vertical asymptotes or x is equal to negative 2 and x is equal to 1. Actually, there is one important thing when you describe this. You can't write vertical asymptotes at x is equal to minus 2, x is equal to 1. Whole means I can say at that point, it's throughout this line, it's a vertical asymptote. Okay, so write it this way. Next one, simple example, first question. Second question, okay, here is a behavior. So at x is equal to -2 and x is equal to +1, we can even judge the behavior. Like x plus 2 is odd multiplicity. So one side up, the other side down, opposite behavior. Okay, how can I say left side is going up, right side is going down? So very simple, just plug in some value. Maybe you can pick some value to the left of -2, which is -2.001, very closer value, and plug in. So my function is 1 by x plus 2 x minus 1. So when you plug in that, of course, I'm taking to the left of 2, so it will be negative. This is left of 1 also, so this is negative. So it will be 1 by some positive. So positive infinity. Just check the sign. Okay, so this will approach. And right side of -2 means anything to the right of 2 will be greater than 2. So this will be positive. This is still left of 1, right? So that will be negative. So it approaches negative. Right? You can plug in some very closer value and check for the sign. That will say which infinity we should approach. Right? And x is equal to 1 also. You can do the same thing. When you put x is equal to 1.001 something. So this will be positive. This is also positive. So totally positive infinity. To the left, if you do, x minus 1 factor will become negative. X plus 2 factor will become positive. Okay, in that way, we can check which side it shoots up or drops down. Okay, so actually this question is just for finding vertical asymptote. And yes, the multiplicity analyzing will be much helpful here. Next one, question 2. Okay, little extra level. First one are so simple, second one here. First thing, vertical asymptote, you should factorize numerator and denominator. So x squared minus 4 can be written as x minus 2 into x plus 2. I have used this difference of two squares identity. And this one we should factorize. X squared minus x minus 6, put across 1 times -6 is -6, middle term is -1. 1, 6 is not possible. 2 times 3, yes, it's possible, and you can give negative for this. So x minus 3 and x plus 2. Now cancel out. You have to simplify the function before finding your vertical asymptote. So x plus 2 get cancelled. This is simplified version. X minus 2 by x minus 3. Now set your denominator to 0. Denominator. X minus 3 equal to 0 implies x is equal to 3. It's a vertical asymptote. Right? So only one vertical asymptote we got here. Okay, here we go. And in this case, we can observe one thing. What is whole here? A possible whole is there. The cancelled out factor will give you the whole. I hope you remember. So whole at x is equal to -2. To find the exact whole placement location, you should substitute in the simplified equation. So substitute -2 here. We can say whole at -2 comma. If you plug in -2 here, -4 by -5. -2, -2, -2, -3. So -4 by -5 is just 4 by 5. Right? Here we can see this. At -2 and somewhere over here we get the whole. Right? So actually this is a whole. It should be an open circle. And vertical asymptote is like this. Okay, my vertical asymptote, I got it from the factor x minus 3. It have odd multiplicity. So one side up, one side down. Okay, how should find one side up? Just plug in. So to the right, 3.001, it will give you a positive answer if you plug in the simplified version. Okay, so if they said approaching positive infinity, to the left of 3, you can put 2.999. That will give you negative value, which means you have to go down. Okay, right, and we are in the third question. A function is given. Find domain, holes, vertical asymptotes. Describe the behavior near the asymptotes. Multiplicity based. So let's start with domain. Domain means don't simplify. Okay, for holes and vertical asymptotes, we will simplify. For domain, no simplification. The raw function, you take the denominator, x, put it to 0. Another factor is x squared minus 1. Put it to 0 and solve for x. So this x is 0. This will give you x square equal to 1, x is equal to plus or minus 1. Don't forget these plus minus 1, plus 1, or x is equal to negative. So you have to exclude this. Domain means denominators will become 0 at certain values. We are going to exclude. So all real numbers except -1, 0, 1. Or in interval notation, minus infinity, place your numbers properly. 0, 1, infinity. We are excluding the values. So you can put a open circle. So from here to here, minus infinity to minus 1, then union, minus 1 to 0, union, 0 to 1, union, 1 to infinity. Okay, so this is interval notation. This is the domain of this function. Right, and let's go. Holes and vertical asymptote. Here we see these points are the function is not working, right? These can be either vertical asymptotes or holes. Okay, they are discontinuities. They are breaking the graph. Either they can be a hole or they can be vertical asymptote, or we will see a jump way also. Okay, so now we are just learning about vertical asymptotes and holes. They are removable discontinuities. Okay. So holes and vertical asymptote. We already had the simplified version, right? Holes means cancelled out one. Okay, so let's go back and check what factors had been cancelled out here. Oh, we didn't. Okay, let's do x square minus 1. If you break, it's x minus 1 into x plus 1. But it was squared, so each factor will get squared. And x into x minus 1 into x plus 1. Okay, now if we cancel out, this will get cancelled, x minus 1. This will get cancelled, x plus 1 by x. This is simplified version. Now what is cancelled out? That is holes. Right? X minus 1 and x plus 1 got cancelled. So that is your hole. So when you solve this to equating 0, you will get where the hole is. So 1 comma what? Holes at minus 1 comma what? So you just plug in the simplified version. Okay, plug in this. And if you plug in 1, numerator will become 0. So 0 by anything is 0. If you put minus 1 also, numerator will become 0. So holes at exactly these coordinates, points, you have to draw the holes. Right, and vertical asymptotes. Okay, vertical asymptotes means in the simplified version, what is left in the denominator, set it to 0. I got only x is equal to 0. That's simple. So which means your y-axis is acting as a vertical asymptote here. Right? That's simple. So we find holes and vertical asymptotes. Now, the last part, behavior near the asymptote. So here we have only one asymptote, which is x is equal to 0. Okay, so you can see to the left of 0 that approaches positive infinity, to the right of 0, it goes to negative infinity. But without graph, how can we do this? Okay, so you have to do limit x tends to 0 negative, means to the left of 0 f of x. Okay, don't take this function, take the function which is in simplified manner. The simplified version is x minus 1 into, okay, actually it's x square minus 1. We don't want factored form here. Anyways, we're going to plug in. So plug in any number to the left of 0. Okay, it will be approximately f of left of 0 is, I can say, negative 0.001. Okay, and try to plug in. So anything squared is positive. Minus 1. And 0.001 square is going to be, for sure, it will be less than 1. Right? And a negative 0.001. So less than 1. This is also negative 1. So this will be negative. Divided by negative, it's positive. We just want the sign, not the numerical value. And limit x tends to 0 to the right, f of x is, you plug in 0.001. Okay. So anything squared is going to be positive, and for sure it will be less than 1. Positive less than 1. Minus 1 by positive. Numerator is going to be less than 1, means like 0.5 or something. Be not 0.5, less than 1. So whichever, so when you solve the numerator, you will get negative sign. By positive, it's negative. Okay, without calculator, we have to analyze like this. Or if you find the first sign, then of course, if it's have an odd multiplicity, x means x power 1. It will for sure next will be downward facing, like downward approaching graph, right? So that's simple. Anyway, we can do. So near using the multiplicity, you can say like this, they will behave opposite way. And to get exactly which side up, which side down, we can work out this, right? So this is the behavior near the asymptotes, and that's it for this video. And here I have a bonus question as usual. Yes, you have to work on factorization. So don't use calculator and graph. Do it all your own by analytical solving. So factor the function completely. Simplify if possible. Find asymptotes and holes. Describe the graph's behavior near each vertical asymptote. Okay, you can drop all this in comments. And of course, we can't do the limit notation here. So you can say as x approaches, your vertical asymptote is a minus, or x arrow mark is possible, right? A. F of x approaches infinity means you can put a capital 0 and a small 0. Or infinity symbol, if you know, you can put it. So this way you can comment clearly in the chat box. And that's it for today. I will be meeting you next video. So stay curious and stay in touch. Don't forget to join the Let's Unbound student community to get the latest updates. For that, you can scan the QR code given here. Keep learning.